I wish all my students a very bright and sunny morning and welcome you all to K-Tech High School and Junior College. Children, let's start our day with good thoughts and positive energy with our lesson number 1, Laws of Motion from Science 1. Today in our lecture, let us learn Newton's law of motion. Children, before starting to learn Newton's law of motion, will you answer me few questions? What could be the reason for the following? First, a static object does not move without the application of a force. The force which is sufficient to lift a book from a table is not sufficient to lift the table. Fruits on a tree fall down when its branches are shaken. And an electric fan keeps on rotating for some time even after it is switched off. Yes, if we look for the reason of all these questions, we realize that objects have some inertia. What do we mean by inertia? The inability of an object to change its state of motion on its own is known as inertia. So we have learned that inertia is related to the mass of the object, right? So Newton's first law of motion describes this very property and therefore also called the law of inertia. All instances of inertia are examples of Newton's first law. So children, let us learn Newton's first law of motion. Children, let's try an activity for this. Fill a glass with sand. Keep a piece of cardboard on it. Okay, cover it with a cardboard. Keep a 5 rupees coin on the cardboard. Now strike the cardboard hard using your fingers. So children, observe what will happen. Yes, if you strike the cardboard hard using your fingers, the cardboard will move and the 5 rupee coin will fall in the glass, right? Now let's learn balanced and unbalanced force. Children, you must have played tug of war, right? It is very interesting game and it's all about applying force, right? So, as long as the forces applied by both the sides are equal, that is, they are balanced, the center of the rope is static in spite of the applied forces, right? So, on the other hand, when the applied forces become unequal, that is, if it becomes unbalanced, so what is happening? A net force gets applied in the direction of the greater force, right? It will move towards the where the force is greater and the center of the rope shifts in that direction, isn't it? So, based on this concept, what does Newton's first law states? It states that an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Okay, children. When an object is at rest or in uniform motion along a straight line, it does not mean that no force is acting on it. But children, Actually, there are number of forces acting on it. They get cancelled one another so that the net force is zero. So Newton's first law explains the phenomena of inertia. So what is inertia? It is the inability of an object to change its state of motion on its own. Okay, and also what does it explains? It explains the unbalanced forces which causes a change in the state of an object at rest or in uniform motion. So, this unbalanced forces also cause a change in what? In the state of an object at rest and also in uniform motion. Understood, children? Now let's start with Newton's second law of motion. Children, let's try an activity for this. Ask your friend to drop one plastic ball and one rubber ball from the same height. You catch the balls. Now, which ball was easier to catch and why? Then ask your friend to throw a ball towards you at a slow speed and you try to catch it. Now ask your friend to throw the ball at high speed towards you. Try to catch it. Which ball could you catch it with greater ease? And why? So the answer to these questions are that the effect of one object striking another object, it depends on both the mass of that object and its velocity. Okay, so the effect of one object striking another object, it depends on both the mass of the former object and also its velocity. This means that the effect of the force depends on the property related to both mass and velocity of the striking object. So children, this property was termed as momentum by Newton. So what is momentum? It is a force that keeps an object moving. Okay, what is momentum? A force that keeps an object moving. So this property was termed as momentum by Newton. Momentum has magnitude as well as direction. Its direction is same as that of velocity. So in our SI system, the unit of momentum is kilogram meter per second. And in CGS system, it is gram centimeter per second. If an unbalanced force applied on an object causes a change in the velocity of the object, then also children, it causes a change in its momentum. The force necessary to cause a change in the momentum of an object, it depends upon the rate of the change of momentum. So children, momentum, which is denoted by P, it is what? It is the product of mass and velocity of an object. That is P is equals to mv. M is mass and V is the velocity. It is the product of mass and velocity. Momentum is a vector quantity. Why it is said to be a vector quantity? Because it has magnitude as well as direction. So Newton's second law states that the rate of change of momentum is proportional to the applied force and change of momentum occurs in the direction of the force. Understood? Suppose children, an object of mass m has an initial velocity u. When a force F is applied in the direction of its velocity, for time t, its velocity becomes v. That is final velocity. Therefore, initial momentum of the object will be what? mu, right? And its final momentum after time t will be mv. So what is the rate of change of momentum then? It is change in momentum upon time. Therefore, rate of change of momentum is equals to mv minus mu, final minus initial momentum, upon t. So we get m in the bracket v minus u upon t, which is equals to ma, right? V minus u is a, acceleration. So according to Newton's second law of motion, the rate of change of momentum is proportional to the applied force. So we can write this as ma is directly proportional to F. Therefore, F is equals to kma. Now what is K? It is the constant of proportionality and its value is 1. Therefore, F is equals to ma. Got it, children? Children, consider two objects having different masses which are initially at rest. Okay. So, the initial momentum of both would be what? 0. Right? Now, suppose a force F acts for time t on both the objects. Then what will happen? The lighter object, okay, it will start moving faster than the heavier one, right? The lighter object will start moving fast than the heavier object. So, however, from the above formula which we have just derived, we know that the rate of change of momentum, that is F, in both the object is same. And the total change in their momentum will also be same. Yes, that is F and T, Ft. Thus, if same force is applied on different objects, the change in momentum is the same. Okay. In SI system, the unit of force is Newton. And Newton is the force necessary to cause an acceleration of 1 meter per second square in an object of mass 1 kg is called 1 Newton. So we can write it as 1 Newton is equals to 1 kg into 1 meter per second square. In CGS system, the unit of force is a dyne. So what is a dyne? The force necessary to cause an acceleration of 1 centimeter per second square in an object of mass 1 gram is called 1 dyne. So we can write 1 dyne as 1 gram into 1 centimeter per second square. Okay. Now let us learn Newton's third law of motion. Children, we have learnt about force, right? And also its effect on an object through Newton's first law and second law of motion. Now, however, in nature, force cannot act alone. It is a reciprocal action, right? Force is a reciprocal action between two objects. Forces are applied in pairs. Now, when one object applies a force on another object, the latter object also simultaneously applies a force on the former object. So, the forces between two objects are always equal and opposite. This idea is expressed in Newton's third law of motion. The force applied by the first object is called as action force. Okay. While the force applied by the second object on the first is called reaction force. So what does our third law states? Every action force has an equal and opposite reaction force which acts simultaneously. Action and reaction are terms that express force, right? These forces act in pair. One force cannot exist by itself. Action force and reaction force acts simultaneously. Action and reaction forces, they act on different objects. So they do not act on the same object and hence cannot cancel each other's effect. Understood, children? Let's begin with law of conservation of momentum. Now as you can see on your screen, children, there is an object. Okay. So suppose an object A, it has mass m1 and its initial velocity is u1, and an object B has mass m2 and its initial velocity is u2. Okay, understood up till here? Now, according to the formula of momentum, the initial momentum of A is what? m1 u1, and that of B is what? m2 v2. Suppose these two objects collide. Okay, they strike each other. So let the force on A due to B be F1. Okay, now this force will cause acceleration in A, right? That means the object A will move and its velocity will become v1. This force will cause acceleration in A, that is, it will move, right? And its velocity will become v1. Therefore, momentum of A after collision will be what? m1 v1. Now, according to Newton's third law of motion, A also exerts an equal force on B, right? But in the opposite direction. So, this will cause a change in momentum of B. If its velocity after collision is v2, the momentum of B after collision will be m2 v2. Are you getting me, children? If F2 is the force that acts on object B, so F2 is equal to minus F1. Why are we indicating with a minus sign? Because it is in opposite direction, right? Therefore, M2A2 will equal to minus M1A1 because F is equals to MA. Now, let us calculate these. M2 into V2 minus U2 upon T is equals to minus M1 V1 minus U1 upon T. Why are we substituting the value of A? Because A is V minus U upon T, right? So M2 in bracket V2 minus U2 is equals to minus M1 into bracket V1 minus U1. So let's open the bracket. We get M2 V2 minus M2 U2 is equal to minus M1 V1 plus m1 u1. So by rearranging them, we get m2 v2 plus m1 v1 will equal to m1 u1 plus m2 u2. It means the magnitude of total final momentum will be equal to the magnitude of total initial momentum. Right? So if no external force is acting on two objects, then their total initial momentum is equal to their total final momentum. So children, this statement is true for any number of objects. When no external force acts on two interacting objects, their momentum remains constant. It does not change. The momentum is unchanged after collision. It gets redistributed between the colliding objects, between the striking objects. So the momentum of one of the object decreases, while that of other object it will increase. So we can say that this is corollary as follows. When two objects collide, the total momentum before collision is equal to the total momentum after collision. In order to understand this principle, let us consider the example of a bullet fired from a gun. As you can see on your screen, children, when a bullet of mass m1 is fired from a gun of mass m2, so its velocity becomes v1 and its momentum becomes m1 v1, right? Now before firing the bullet, both the gun and the bullet are at rest, and hence the total initial momentum is 0, right? Now according to the above law, the total final momentum also has to be 0. Thus, the forward moving bullet causes the gun to move backward after firing. This backward motion of the gun is called its recoil. Okay, so the velocity of recoil, that is v2, is such that m1 v1 plus m2 v2 is 0, or we can also write it as v2 is equals to minus m1 upon m2 into v1. As the mass of the gun is much higher than the mass of the bullet, so the velocity of the gun is much smaller than the velocity of the bullet. Are you getting me? The magnitude of the momentum of the bullet and that of the gun are equal, and their directions are opposite. Thus, the total momentum remains constant. Total momentum is also constant during the launch of a rocket. Understood, children? So, children, today we have finished our lesson number 1, Laws of Motion from Science 1. I hope, children, every one of you must have understood the lesson. Children, please watch the video carefully and attentively and then read the whole lesson. We shall see you in the next video with a new lesson. Till then, thank you. Take care of yourself, children.